In this lesson, we are going to be talking about proving two triangles are congruent, and we're going to get into doing what's called two-column proofs. So we're going to start with an algebra proof. So we're going to take and solve this equation. And what you do with a proof is you write down your steps on the left and you write down your reasons, your justifications, and they have to be math rules. So on the left here, on the right, okay? So we'll do the statements on the left and the reasons on the right. So you always have to be given something. And so it's just the facts of the problem. So often it's on the picture or they're going to actually give you some information. So that's going to be called the given. It's our starting point. So right now we're given this equation that we're going to solve. So I'm just going to show the reasons and then we can do the steps on the other side. So the first thing that we would do in this problem is do the distributive property. So we're going to distribute this 2 in to get and then you write down your next part. So we'd have 3x, and then 2 times 2x is 4x, 2 times 9 is 18, and then we have that equals negative 10. So all we did in this step was the distributive property. Next, what we would do is combine our like terms. So our like terms are the 3x and the 4x here. So that would be 7x plus 18 equals negative 10. And so you can kind of see that these are just being split up. Each step has a reason that goes with it. And then the next one that we would do is subtract. And this is, so we're going to subtract 18 to both sides. And you don't write down the subtraction, you just do the subtraction yourself. So subtract 18 from both sides. So when we subtract 18 from here, we'll be at negative 28. Okay, and then the final step is to divide. Whoops, that's going to move the whole thing down. Okay, so then to divide, so we'll divide by 7 to both sides. And that's going to be negative 4. So this is actually the subtraction property of equality is the long title. And then divide, so is actually division property of equality. But you can say for our class, you can say subtract to both sides or divide to both sides. It's just justifying your steps over here. So what we're going to do today is take a look at two-column proofs with geometry, okay? So two-column proofs are just, like I just talked about, a logical argument of statements. So they're going to follow some type of order, okay? And we're going to put down what we know and how we know it. So geometry is like the lawyer of mathematics, okay? So you're trying to present your case to the jury through this two-column proof. So you're going to say, what do you know about it and how do you know? And this needs to be factual. It can't be, it looks like it, I think it is, okay? It has to be an actual math rule. So let's take a look at these triangles over here. So we did a lot of these the other day, okay? So what we're trying to do is determine whether these are congruent or not, okay? So you want to look at the picture and decide if it's even possible before you get started. So we do see vertical angles here that we marked up the other day. Okay, so we know that vertical angles are congruent. Then when we look within this triangle, we see 2 angles and a side. So we see 2 angles and then that side is not between them. So we're going to put the S not between the A's. So these 2 triangles are in fact congruent by angle, angle, side. So that's going to be yes. So like I said, we're likely going to start with some givens. So in this case, it was a picture over here. So what you're going to do is write down what exactly you were given. So this tick mark and this tick mark is something you were given. What does it say? It says that side PQ is congruent to side TS. Okay, you were also given this arc mark here and this arc mark here, which tell you that angle Q is congruent to angle S. Both of those are givens. So in your reasons, you will just say that you were given them on the picture. Then what we did was marked up this angle right here, okay? Now this one, there's angle R is in the left and the right, so you can't just call it angle R. So we need to use 3 letters. So we'll say angle PRQ is congruent to TRS, so angle TRS, and Y, because they're vertical angles. Then your final statement, okay, is to prove what you were doing. So you were proving the triangles were congruent. Okay, so now we'll write the first one, triangle PQR, I like to write them in alphabetical order, is congruent to what? Okay, so triangle PQR is congruent to, so P goes with T, so triangle T, Q is with S, R, and then how do you know which was one of these? Okay, so we said we know because of angle, angle, side. So what were you given? You marked this up. How did you know? And then your final step is to prove what you were supposed to be proving. Okay, next one. So are these triangles congruent? So again, look at the picture. So there's nothing else we can mark on this picture. There's no vertical angles or reflexive sides, but we do have this extra statement down here that we can mark. So this one says C is the midpoint of BE. What does midpoint mean? Midpoint means it splits the piece or the segment into 2 equal pieces. So we know that these pieces are congruent, which then gives us all 3 sets of sides marked as congruent, which is one of our ways to prove that triangles are congruent. So these are congruent. So now we're going to go ahead and put it together in a logical order. So we've got what was given to us. So we've got this segment and this segment. So AB is congruent to DE, okay, which was given. Then we were also given that segment AC is congruent to segment CD. Okay, so those were the marks on the picture. That was given. Okay, then we were given this statement. Now you actually have to write out that statement because that's what you were given. C is the midpoint of BE. Okay, that whole statement is what you were given. Okay, so write it out. Then you did something with it because it has a word. So in order to mark it up on the picture, we had to know what this word midpoint meant. Okay, and what midpoint meant to us was that segment BC was congruent to segment CE because we know the definition of a midpoint. Then we were able to say that the triangles were congruent because now we have all of that on the picture. So triangle ABC, so triangle ABC is congruent to triangle DEC. And then how do we know that? Because all 3 sets of sides are congruent. Last example, so taking a look at these triangles here, okay, so I'm just going to start writing the givens in here. So we've got WY is congruent to XZ, that was given to us, okay, so that's our given from the picture. That's our one thing that was given to us as congruent. Then I'm going to write down, so we see this we see this reflexive line here. So we're used to doing that. So the reflexive side is this middle piece. Okay, so reflexive means that that segment XY is congruent to itself XY. Okay, so XY in the top triangle is congruent to XY in the bottom triangle because of the reflexive property. Then we don't have enough information on the picture yet. Okay, that's not enough markings, but we still have this other given statement that WY is parallel to, so remember parallel, you can do those two vertical lines like that for parallel, is parallel to XZ. And then, so what can we do with parallel lines, okay? So then we learned a bunch about parallel lines. So these lines right here are parallel. That doesn't give us anything that's congruent, okay? But if we look at these as our parallel lines and this as our transversal, we end up with these angles right here being equal because they're alternate interior angles. So this was the given, I forgot to write that in. Okay, and then we've got parallel lines, we've got alternate interior angles. So I'm just gonna actually draw a little 1 in here and a little 2 in here to say angle 1 is congruent to angle 2 instead of writing out all the letters. But let me erase that on that picture so that you can see it a little bit easier. So alternate interior angles actually make a Z. So when you have a parallel line, so this line is parallel to this line, and then we have this Z here. So the angles in the corner are alternate interior angles when these lines are parallel. Those are congruent. So now how do we know that the two triangles are congruent? Well, like I said, you can redraw this triangle to kind of simplify it. So I'm just going to redraw this top triangle. So I have this side marked, I've got this angle marked, and I've got this side marked. So we've got two sides. So this side and this side, and then that angle is between them. So we know that the triangles are congruent by side angle side. So now it's just writing out the order. So choose the order for your first one. So I like alphabetical, so triangle WXY. So WXY is congruent to what? Okay, so WXY, so what angle goes with W? That's Z. Okay, so WXY, so this X right here didn't have an arc mark in it. So in this triangle, that's this one. So ZYX. And they're congruent by side angle side.